This graphical organizer could be helpful. You could use it to figure out some things, but once again, unit conversions just work out. But whenever you're going from atoms or molecules to moles, you're going to divide. When you're going from moles to atoms or molecules, you're going to multiply by Avogadro's number. And when you're going from moles to grams, you're going to multiply. And when you go from grams to moles, you're going to divide by the molar mass or the atomic mass. So our first example, calculate the mass of 1.75 moles of hydrogen. So we're looking for our given. Let's go ahead and do is 1.75 moles. It really matters what it is, so we're going to put H2O. Then we're going to calculate the mass. So we're looking for grams. In this case, we're looking for the grams of water because that's what we have. So we're going to go from moles to grams or moles to mass. And so we're going to have to use the molar mass, which we found a little bit ago, to be 0.02 grams per mole. If you forget, you can look on the periodic table. Water 16, hydrogen 1.01 times 2. Add those numbers together, you get 18.02. Always start with what they give you. We're going to use our conversion factor. We have to get rid of the moles. So we're going to get 18.02 grams over 1 mole. That's what that per means, and it's implied that it's 1. So get out your calculator. You're going to multiply the numbers together. You get 31.535 grams of H2O. And then we need to do sig figs, so we need 31.5 grams H2O. And then let's check and make sure that this number is realistic. Hey, the molar mass is 18.02. We have more than a mole, so we should have more mass than that when we do. So that's a reasonable answer. Example 6.2a, calculate the moles of sulfur and 57.8 grams of sulfur. So our given is 57.8 grams, and it's S for sulfur. Our find is the moles, because this is calculating the moles. So we need to go from grams of sulfur to moles of sulfur. We're going to find our molar mass. 1 mole of sulfur equals 32.07 grams. So that's our conversion factor is 1 over 32.07. We need that number on the bottom because it needs to cancel out the grams. Put it in, plug it into your calculator, do sig figs, and you should get 1.80 moles of sulfur. You should go ahead and try to do the next couple problems, and I'll show you the answers. So if you need some time, pause that, and we'll move through. So we are given that we have 2.21 times 10 to the negative third moles of C. So calculate the grams of in 2.21 times 10 to the negative third moles of carbon. We need to figure out the grams of carbon. So we're going to use our molar mass. I probably go out to the 12.01. We're going to start off with our given. We want to go to grams, so we're going to need that molar mass. And then there's 12.01 grams for every 1 mole. And we're dealing with carbon. Take out our calculator, plug them together, we get 0.0265542 grams of carbon. Do sig figs, and we end up with that 0.0265 grams of C, or you could have 2.65 times 10 to the negative 2 grams of C. Either one of those answers would be fine. Example 6.5, how many molecules are in 50 grams of lead 4 oxide? They give you the molar mass. We're starting off with 50 grams of lead 4 oxide. We're trying to figure out how many formula units. It's really a formula unit, not a molecule. Your book interchanges those. So we got the molar mass is 239.2 grams, which is equal to 1 mole, which is also equal to Avogadro's number. So you can do that conversion right away like that, and you get the answer. To be realistic, I'm probably going to do this in 2 steps. So I would start with the 50 grams of the lead 4 oxide. I use the molar mass to go from grams to moles. 239.2 grams per 1 mole. My grams cancel, so now I'm in moles of lead 4 oxide. And then I don't want moles, I want particles, I want molecules, I want formula units to be accurate. And so I'm going to use 6.022 times 10 to the 23rd, and I'll get the same answer. Either way is fine. So as long as you can show your work and get there, that's great. One more practice for you. How many copper atoms are in the copper wire weighing 3.10 grams? So our given is 3.10 grams of copper. We're looking for atoms of copper. So yeah, I go from grams to atoms. So I might do 2 conversions, as I said. So I'm actually going to go from grams to moles to atoms of copper. If you can do it in 1 step and show your work, that's fine. 3.10 grams of copper. When I go from grams to moles. And I want to go to atoms. So there's Avogadro's number for every 1 mole. Plug it into my calculator. Get 2.94 times 10 to the 22nd. Copper atoms, which is the number I was supposed to get. So conversions, sometimes you need 1, sometimes you need 2. Sometimes you can use 2 conversion factors to make 1 and then do 1 step. I personally find it easier just to do it step by step, whatever works for you. Another practice, you should go ahead and pause and go ahead and do this one. If you need some help, you can watch the video, and if you need more help, contact me during my office hours. So what's the mass of 4.78 times 10 to the 24th NO2 molecules? So the given is the 4.78 times 10 to the 24th molecules of N2. And we're looking for mass, which is grams of the NO2. So we're going to go from molecules of NO2 to moles to grams of NO2. Our molar mass of nitrogen dioxide is 46.01, and to go from moles to particles, we're going to have Avogadro's number. So we need those 2 pieces of information. Once again, you always start with what they give you. I'm just going to write it as NO2. It's implied that it's the molecule because it's covalently bonded. I want to go from molecules to moles, I said, so now I'm going to go put moles on top. And I need to use Avogadro's number. 6.02 would work, but I might use 6.022 because that's what we've been using on the other sides. And then that will get me into moles, but I don't want moles, I want grams, so I need to use the molar mass. I want to get rid of moles, so I had to put 1 mole on bottom, which means I get grams on top. And get out my calculator. 4.78 times 10 to the 24th divided by the 6.022 times 10 to the 23rd. Be careful about making sure you use order of operations correctly. Multiplied by 46.01. It's going to give me units of grams of NO2. Get 365.207 with 3 sig figs. That's 365 as we're supposed to get. So we're going to talk about mole relationships when we're dealing with the chemical formula, but we're talking about like atoms. So if we have 1 mole of NaCl, that means we have 1 mole of the sodium atoms and 1 mole of the chloride ion. We had 1 mole of H2O, then hey, there's 2 moles of hydrogen for every 1 mole of H2O, and there's 1 mole of oxygen for every 1 mole of H2O, because there's only 1 oxygen in that compound. We have 1 mole of calcium carbonate, then we'd have 1 mole of calcium, we'd have 1 mole of carbon, and we'd also have 3 moles of oxygen. And then we have 1 mole of glucose. We'd have 6 moles of carbon, 12 moles of hydrogen, and 6 moles of oxygen. If we had something like CH3OCH2CH3, how many moles of hydrogen atoms would we have? Well, we'd have 3 moles here, but we'd also have 2 moles here, and we'd have 3 moles here. That would give us a total of 8 moles each. So here we're going to do another little example. So calculate the moles of oxygen and 1.7 moles of calcium carbonate. So we go look for our number, find our given. We got 1.7 moles of calcium carbonate. Calculate the moles. So we're looking for moles, and in this case we're looking for moles of oxygen. So how many moles of O there are? We're going to moles of calcium to calcium carbonate to moles of oxygen. Every 1 mole of calcium carbonate, there are 3 moles of oxygen. So we're going to need our mole ratio. It's a little different than what we've been seeing. We start with what they give us, 1.7 moles of calcium carbonate. We need 3 moles of oxygen for every 1 mole of calcium carbonate. Do the math and you get 5.1 moles of O. You just cancel out to work. Find the mass of carbon and 55.4 grams of C10H14O. So the first thing we need to do is figure out what they give us. So we find our number and what type of units in this substance it is. What are we looking for? We're looking for the mass, but we're looking for the mass of just carbon. Find the mass of carbon. So we're going to go from grams of the C10H14O. We're going to go to moles because we don't know the mass ratio of this. You could probably figure out another way to do it using mass, and that would be fine. And we're going to go to moles of carbon, and we're going to go to grams of carbon. So we're going to need some molar masses. We're going to need the mole ratio from the compound to the atoms of carbon. And so we put our work together. We start off with what they gave us. We then are going from grams to moles because this chemical formula tells us a mole quantity. It does not give us a mass quantity. So we have to use the molar mass of C10H14O, so 10 carbon atoms, 12.01 each, plus 14 hydrogen atoms, 1.01, plus 16 gives us 150.2. And grams go on the bottom to cancel out with grams. Do a mole ratio for every C10H14O. There are 10 carbon moles. Multiply by the molar mass of carbon, then we get 44.3 grams of carbon. So you should go ahead and try to do this problem. Find the mass of sodium in 6.2 grams of sodium chloride. Make sure you're careful and remember that you have to do a mole to a gram to mole conversion, a mole to mole conversion, and then back to the mass conversion. If you didn't get the correct answer, you should go ahead and contact me.